Hello, everybody. I'm Dean Richmond with Nextivity, and today we have Steve Van Skyke going to talk to us about Cel-Fi QUATRA antenna selection. So has a lot of great material for you. Myself and Emily are going to be working in the background looking at your questions, and we are probably going to, every once in a while, poke into Steve and say we have a great question. A majority of these questions are going to be fielded at the end. So with that, Steve, are you ready?
I am ready. Thank you very much, Dean. Again, my name is Steve Van Skyke. I'm a solutions architect for Nextivity. And this webinar today is going to focus on the donor antenna side of off-air in-building installations and how good antenna choices can have a major impact on overall system performance. For those of you that aren't familiar with our company, Nextivity is an engineering company founded in 2006 in San Diego. We make solutions for about 200 operators around the world in 100 countries. And this specific presentation is more to the tune of Quatra, but the same principles, of course, would apply to any system that you are installing. We're going to talk about the donor signal and why the best donor signal you can get is something to certainly strive for. We're going to talk about antenna characteristics beyond gain, impedance, frequency, etc. We're going to take a look at the best donor signal, the serving cell site that you should be targeting. We're going to talk about antenna placement, our CelFi antenna lineup, and go over site surveys. It's really your key to success is taking some measurements at a site ahead of time so that your planning decisions will be sound. And then we're going to take a look at our portal because there are a number of tools in the portal that will help you along the way, make sure that things are optimized. And then we'll take a look at some scenarios. All right, I always like to take a project and separate it into two pieces. You have the donor signal source. This is your donor antenna or small cell, but in this case, we're going to concentrate on a donor antenna to the macro network. And you have RF distribution and management, which would be your Quatra system or some other CelFi system that might be attached to the donor antenna. So RF distribution is pretty easy. Planning is not too difficult and deploying systems fairly routine, but the art of this that really comes into play is when you are working on your donor signal source. All right, these snapshots were actually taken off of my phone. And what I'd like to show here is, this is about your customer's perception. Being able to make phone calls is one thing, but how many bars they see on their phone is another thing. And of course, usually if you see more bars, if those bars are indicating signal quality, that'll also translate into higher data rates. If you take a look at the left side picture, this is showing 4 out of 5 bars. Now this is actually not a super strong signal. It's -105 RSRP, but the signal to noise ratio is not bad. It's +5.4 dB. And yet, even though it's a low signal level, you're showing a lot of bars on this, quote, customer's phone. But if you take a look at the picture on the right, it's still my phone, but it's only showing 2 bars. Now, this signal is very, very strong at an RSRP level of -64, but the signal to noise ratio is -1.5. Right? So even though it has a much stronger signal, it's showing fewer bars. Now this is kind of a clever way for, newer Samsung phones do this, iPhones do this. They take signal quality into account when they calculate the number of bars to display. So if you have a poor donor signal coming into your system, you can have all the power you want, but you still may only show a couple of bars on your phone, and that may not be a pleasing sight for your customers. So again, we're really going to concentrate a lot. Please keep signal to noise in your mind in the background, because that's really what we're trying to maximize here.
So before you go on, Steve, we had a question on what app are you using to do that measurement?
Everybody has their own that they prefer. I like to use Network Cell Info Lite. I'll go back to that screen. And the reason is because it shows the RSRP level, it shows SINR, our signal to noise ratio, and it also shows RSRQ, which is a little bit more related to quality. There's LTE Discovery, and there's a number of other ones out there. This app running on I have a Samsung phone, oops, also shows the band, which is really handy, right? Because when you're doing these measurements, you really are interested in what's happening for an operator's channel in each band as you're trying to qualify your signals. So Network Cell Info Lite is the one that we're looking at right now.
Perfect.
And I take screenshots, by the way. It's really handy. We decode the overhead information so we can see all of that on the portal. But if you want to take a look at what a handset is seeing, that's where these apps come into play. And being able to take a screenshot and text it or email it to somebody is a very nice thing to be able to do. All right, so getting back into other antenna characteristics, of course, there is beam width. Now, the whole point of having a directed antenna is to try to pick up the signal from a specific target cell site and not from the other interferers that are in undesired directions. Now with a CelFi system, remember we have 100 dB of maximum signal gain. We are not necessarily locked into aiming our antenna to just the strongest one, just the closest tower, because we have to be able to maximize the gain that we have. We have 100 dB of gain. So in this sense, we are more apt to use our antenna as a filter, right? I want to point it at the tower that I'm interested in and reject all of the interference that's coming from those other directions. The desired signal over the undesired noise, if you will. In this case, we have a panel antenna that I'm actually looking at 2 different cell sites. And remember, if those cell sites are different distances away, so their power levels are coming at me at different donor signal powers, we'll just apply more gain to the one that's weaker and normalize everything. That's a benefit of a CelFi system. Now, if you have more of a problem signal to noise ratio, let's say a lot of pilot pollution, you're close to where freeways are merging or you're high up in the building, then you may want a tighter beam on your antenna. Here's our log periodic antenna. And this is a great antenna if you want to narrow in on just one tower, just one carrier. So it has even a better chance of rejecting interference from those undesired signals. Now, something else that people don't talk about all the time, because we're always so focused on the main lobe, right? Our main antenna pattern. What about behind that antenna power, the back lobes, the nulls? This is a concept called null steering. It's a little bit advanced, but you'll notice that when you are aiming an antenna, just a few degrees left and right might have an effect on your signal to noise ratio. And it could be the noise contribution that that antenna is receiving because of these nulls. So you might find that if you move the antenna just a little bit, you may improve your signal to noise ratio. And this is just a graphic representation of that, where the antenna was shifted a little bit. So our desired tower is still well within the main lobe of the antenna, but we're using one of the nulls in order to reduce interference from this undesired cell that may be close and giving us a problem. Next is the front to back ratio of the antenna. This is the gain in the desired direction versus the back gain of the antenna expressed as a ratio in dB. And of course, you know, when you have a higher gain antenna, your front to back ratio tends to be higher. And we're really using that to provide isolation to the DAS equipment that is inside the building, or hybrid DAS equipment, because we don't want uplink energy coming back in through the server antennas or the coverage units, and similarly we don't want downlink energy feeding back into that donor antenna. So the more isolation you have, the better. And I'll show you a little bit later on when you're taking a look at the portal. The system actually measures that for you. So there's really no guesswork here. You know, you'll go through the art of antenna placement and aiming, etc. But at the end of the day, the portal will help you actually measure how well you did, and you can make adjustments along the way if those measurements don't go the way that you intended. Now, another important aspect of an antenna is its polarization. LTE antennas, base station antennas, tend to be plus and minus 45-degree polarized, right? So these are completely unique transmission chains that are transmissions that are polarized orthogonally to each other. Now, if you take your antenna and you match one of the polarizations of the base station, then you'll pick up an additional signal to noise improvement, 3 dB actually on paper. So our LPDA antenna, as an example, in the one that we're seeing here is actually a MIMO setup where we've used 2 antennas, and one is polarized at plus 45 and the other is polarized at minus 45 degrees. But if you have a single antenna, such as for a Quatra 2000, you can use just one polarization is fine, but the mount is in the box in order for you to polarize, mount the antenna properly, and pick up that additional signal to noise benefit. Serving cell, this is also very important. When you're performing a site survey, you know, we walk a building and we look at the PCI. We want to know the cell ID of the current serving cell for that building. And you know that when you walk around buildings, you tend to jump around a little bit. You know, maybe in the west wing you have a cell that's dominated that side of the building, and on the east side of the building it's a different cell, or maybe one cell seems to be dominating the building quite well. If you do have dominance from a particular cell site, then it's best if you can relay that same cell site. That way the signals reaching the handset just look like a multipath coming in from that same cell, and you aren't creating additional overhead because you're not introducing handoff. But what do you do if that cell site is a problem? You know, maybe speed tests are showing that there is specific downlink interference or specific uplink interference, or maybe there's a bad traffic pattern because it's close to a freeway and you really don't want to use that cell because it's a problem. Then you can switch to a different cell site, a different target cell site that you think will produce a better service for the inside of the building. Now, if you do that, you have to make sure that your signal dominance, you should dominate over the ambient power level in the building by about 6 to 8 dB. And this is just to ensure that you don't go into handoff between the two cells. You want to try to keep everybody on one tower if you can. But this is an option. Again, remember, if the signal's a little bit weaker, we're okay with that because we have the gain. We'd rather bring in good service. Now, I really like to do speed tests. With my phone, it's hard to get directionality, but you can do it by going to different areas within the building. I could go to the west side of the building and do some speed tests, and I'm using the building to block signal energy coming from the east, north and south, let's say. And then I'll go to the east side and I'll do a bunch of speed tests. And you should take more than one because results can vary. And you always want to do these kinds of tests, all of these tests, during normal business hours. Don't do it at night because the traffic patterns on the network will be different, most likely, than they are during the daytime. And that can have a large effect on the outcome of your system. Everything looks great when you install it, but then when everybody shows up to work the next day, it's not working the same way because those traffic patterns have changed. The nice thing about the speed test, it doesn't just give you the speeds up and down, but it shows you how well the uplink is behaving and how well the downlink is behaving. If both of those aren't in the megabit range, then you could end up with some problems. And then we also, of course, have the building itself, using it for isolation purposes to create additional isolation between your donor antenna and your hardware that's in the building. We always want to get to max power, and your CelFi systems they'll never go into oscillation. They employ an echo canceller and they adjust extremely quickly to always maximize their gain and power. but your job is to make sure you have enough isolation that everything is always at max power and you have your maximum footprint from all of your coverage units or service antennas. But then you can run into those cases where there may be a building across the street that is causing a reflection back into the windows below and actually reducing your isolation. In a case like that, you may want to do something with your antenna's direction, right? Point it away from that building or something. I've seen this happen plenty of times. You know, you come up with a plan, you go to a site, you execute the plan, and then something happens and you may never figure out why. It was a forced air unit duct, an air collection system that is actually channeling energy into the building, and it's spilling out right next to a coverage unit, something like that, right? But measurement is key. All right, elevation is important on your donor antennas. You would like always a line of sight path between your donor antenna and the serving cell site that you've chosen. And you'd like to go with the lowest elevation possible where you can still see that cell site. The reason is because as you go higher up, you may still have line of sight to your target cell site, but that antenna is also going to see a lot more interferers off in the horizon from other base station antennas, and that's going to mean some pilot pollution, and that is again going to reduce your signal to noise ratio. So try to place your antennas at the lowest elevation possible where they can see your target donor cell site. And if multipath exists, you know, ideally you really don't want to, this won't always be the case, but ideally you don't want to aim an antenna off of a multipath to a tower because it's less stable. You'll see higher fluctuations. Now, our gain will track in real time, so if the signal power level goes up, we will reduce our gain. If it goes down, we'll increase our gain. So we will try to normalize that for you. There's nothing that you have to do, but you may see more noise-related problems. And again, we're always shooting for the maximum signal-to-noise ratio. So line of sight is always best. Spacing, I love this picture. You know, we all go to the roof and we see a lot of antennas, and you want to make sure your antennas, of course, have some separation distance, maybe 3 to 10 feet at least between these other antennas on the roof, because you have no idea if they're transmitting or receiving and what their frequencies of operation are. If you look at all these, of course, they are all pointed away from each other with some distance, except one antenna. I love this one in the back here. It seems to be pointed at a lot of the other antennas. That guy could be having a problem. You know, if it's a receive antenna, it might be pulling in some noise from these other antennas that they're transmitters. If it's a transmit antenna, then it could be, if it's transmitting, then it could cause a noise problem for the other antennas that are in its main bore site. So obviously not the best thing to do. You know, you can overload your receiver with even out-of-band energy coming in from somebody else's antenna that's transmitting, or there could be PIM issues, or just plain raising the noise floor. You know, these channels from transmitters are generally very well filtered with cavity filters a lot of times, but there will still be some phase noise, still some noise outside of their bands, which will increase it, because nothing's perfect. It will increase the noise floor, and if they're anywhere near your frequency of operation, they could cause you a problem. So a little bit of distance is to your benefit. All right, here is our current antenna lineup. We have the LPDA antenna, which is the large antenna with the most gain and the best front to back ratio. If you have signal to noise ratio problems, or you want to point your antenna for a single operator, this is really the way to go. It does come with that polarization mount, as I mentioned. You can choose either plus or minus 45 degrees, but again, that will improve your signal to noise. I've seen just wonderful results with this antenna over anything else. You know, it just does the best job if you're targeting that single cell site. If you'd like to capture, if your signal to noise is okay and you only need to clean it up a little bit and you want to be able to capture more towers off of one antenna, the MIMO panel works great. You can use it with the Quatra 1000 or 2000. It actually is plus or minus 45-degree cross polarized internally. It's actually two antennas in one box, so you get that signal to noise benefit. It just is not as tight a beam as the LPDA antenna here on the top. And then on the bottom, we have our dual feed omnidirectional antenna. This would be the least apt to clean up any kind of signal to noise, but if your SINR is really, really good for all the operators you want to serve, then there's no reason why you can't use this antenna. And a good example would be closer to the street where there's just too much interference high up in the building and you can't get decent channels for your operators. And then the Omni down closer to the street level could easily be your solution. And,
hey, Steve?
Yep.
We've got a couple questions in here. We've actually been answering dozens and dozens of questions along the way, but a couple that I did want to put out to you. What happens when you have two different optimal cell towers between the traffic and non-traffic hours? How do you determine what location and where to point it?
That is a tough question. Ideally, you will choose one, but if you were to take two LPDA antennas and aim one at one tower and one at another tower, then I'm trying to, you know, this is something you'd have to test it on site and see what's going to happen, because when you have two different antennas pointed in different directions, if they're LPDAs, I would only ever do this with an LPDA, and we do this all the time. Usually it's between carrier A and carrier B. You do get the benefits of each one, but there is a noise addition from the other antenna. So for example, if I'm pointed at tower A, which seems to be better during the day, and I'm pointed at tower B, which seems to be better at night, and I need 24/7 service at this site, I would want to honestly run a test. I would certainly try to point an antenna at each direction and then sum them together and then bring them down into the system. And it depends on how much interference there is. Probably the most important factor is how much interference there is from other cell sites that you don't care about besides just these two. If it's just these two, you may be fine, and you would probably receive an improvement from that. You'd have to do some measurements on the site though.
Okay, and then when you're installing the donor antenna, how much elevation do you need to achieve the things that you're talking about here?
It's about line of sight to the serving antenna. In reality, it isn't like a laser beam. If you look up a term Fresnel zone, the transmission pattern between a transmit and receive antenna is actually a parabolic region between the two antennas. So something that enters that parabolic region, even though it isn't blocking your line of sight, will actually have an effect on the energy transfer between the two antennas. What I'm getting at is, if I go to a low elevation and I'm looking across the building next door, and just a few feet above it, I can kind of see the tower at some far off building, someplace else, that's not good, because it's not, even though I can see it and it's line of sight, really half of my view to that antenna has been blocked. In that case, I'd want to actually up tilt my antenna a little bit and not have that Fresnel zone so impeded by this other structure. So it just depends on the site, right? You've got to see where your tower is, and again, you can always take measurements, right? Do the measurements.
Yeah, so I guess more specific, how much elevation above the rooftop are we talking?
Oh gosh. Most people, I've seen so many different things on skids. I wouldn't have something sitting 2 feet above the rooftop and 20 feet in from the edge, or 10 feet from the edge. I wouldn't do that. I'd have it at least up around 4 or 5 feet with say the LPDA antenna, just to get away from other structures on the roof and not impede that parabolic space that we're talking about. You know, if you take any antenna and you put it too close to other structures, you could also create PIM reflections, detune the antenna. You know, there's other things. So you need to keep a little bit of separation. So I would easily go for 4 or 5 feet minimum above the roof of the antenna if I could.
All right.
Roof of the building.
And I'm gonna end my public questions here for a little bit and concentrate on that Omni. Your answers were kind of heavily weighted on the LPDA. The question were, what about the Omni? You've got a 4-carrier solution out there. When to use that Omni versus the LPDA or something else, I guess, than the Omni, if you're going with the 4.
Right. I mean, the omnidirectional antenna has the obvious benefit that it does not have to be aimed. It's kind of like being on the roof with your handset in your hand, right? But if you take a look at all of your channels from your carriers, remember the way that our system operates is if you have a Quatra 2000, you have 2 carriers on one system and you have 2 carriers on the other system. So you really only need to worry about 2 carriers for each system against which antenna that you choose. The Omni is going to receive interference from all directions. What is good interference? What is bad interference? If you see, you know, SINR generally goes from, let's say, -10 dB to +30. Anything above 0 is okay. I like to see them above 5 dB. When you start getting into negative territory, -1, -2, -3 dB, just as I showed you on that earlier slide, you're starting to see less bars on your phone. Once it gets south of -6, -7, you can start having call drops, right? So take your measurements when you're doing your site survey before you choose your antenna. And if it were my truck, I'd always have another option or 2 on the truck, because once you get up there and you actually install a system and take measurements from it, see what's going on, there's always a possibility you may have to change your mind on what antenna that you used, right? But the chances go down if you've done a good job of a site survey. Okay, now there's a couple ways that we try to help along the way. These are not on our website, but you can contact us if you'd like to get any of these other materials. Of course, we have online training, but there's some other things that we have. For example, a site survey form. This is a handy guide to remind people of the questions to ask and the things to look for when they are performing an actual site survey. And the second section in particular is to help us remember to take measurements inside the building and outside where we think our donor antenna is going to be. Inside, because we want to know what the current serving cell is, what's dominating throughout the building. We also want to know if we have a lot of signal of poor quality, that's interference that we're actually going to have to dominate over, because that would mean more hardware. Or if it's strictly a coverage problem, maybe it's a warehouse or an underground parking structure where you have no interference and it's really just a coverage problem, then it actually takes less equipment to do that. But you have to measure in the building to find out. And then outdoors, of course, because you're going to take speed tests and take some measurements on different sides of the building to just figure out which direction that PCI is coming from, or where you're getting the most reliable signal and the best speeds up and down from. That'll all weigh in as you choose your antenna site mounting location. Then there's also a step-by-step guide, which takes you through the entire Quatra process, everything from getting access to the portal, and doing a site survey, doing your site plans, and testing at the very end to make sure you've optimized everything. That's all in the step-by-step guide. On the portal, we added some information a month or two ago to help people. You know, it's one thing to go through training, but when you actually get out there, you forget part of it, right? So these alert icons will show up as colored icons if one of the RF parameters looks like it should be improved. And if you hover over that icon and press on it, a window will come up with some guidance. In this case, radio A is doing band 2 LTE, and the signal to noise ratio is south of 0, right? It's -4, it's not good. So there will be some helpful information. Maybe we need to change where the donor antenna is, or change the donor antenna, or aim it or polarize it if we didn't use that mount, something like that to improve your signal to noise ratio. Similarly, I talked about isolation. If you click on a coverage unit, you'll start getting real-time information about what the coverage units are seeing. And this downlink echo parameter is your window into how well things are going from an isolation perspective. And again, there's information on this. So you can turn off coverage units until you see your gain and power go up, and then you'll, through this trial and error method, be able to figure out which coverage unit might be causing a problem, and then you can move it or isolate it a little bit better and get your power up. So use the portal as a guide when you're doing your installs to improve things if necessary. All right, just a quick, I'm going to run through some quick scenarios just to exemplify the things that we talked about today. In this example, this is kind of the de facto standard. I've put my antenna on the top of the building and pointed it at what I believe to be the best tower. But let's say there's a problem with that tower, and I actually need to look for a new donor. So in this case, I've moved my donor antenna to the other side of the building because I found another tower that had much, much better service. And that's what I wanted to bring into the building. And I'm actually using the structure of the building to block energy from this undesired tower. So I've lowered the elevation of that antenna, but I still have a good line of sight to my new donor site. Now, in this case, the antenna has been changed out because the customer doesn't want to see this larger antenna on the roof. Maybe it's a hotel and they care more about aesthetics than anything else. So here they have changed out that LPDA antenna to a panel because it's a lot easier to hide. It won't have as good a effect on the signal to noise, but it's still a good antenna and much easier to place in a place where it can't be seen. Now, in this case, there just wasn't any decent donor signal up on the roof. Heavy pilot pollution coming from all directions. What do? You know, a lot of times you'll see this in a downtown at a city. You might find that there are serving cell sites down at the street level for pedestrians, and those are fine, right? They're actually well shielded from all of that pilot pollution that exists at the higher elevation. You could choose either a panel or the omnidirectional antenna down here, because maybe you've got it at an intersection and it can look down all 4 directions down the streets and it's picking up pretty good signals. That's fine to do if your signal to noise ratios are adequate on all the channels that you're bringing into the building. Okay, just a quick summary of what we went over today. First, break your project up into 2 pieces, RF distribution and the donor signal source. RF distribution is easy. Donor signal source, again, the art of a well-performing system at the end of the day. Make sure you get a good quality signal in, of course. We took a look at things other than frequency and impedance and those other parameters on an antenna. We looked at bandwidth, beam width in order to reject interference coming from undesired directions. We looked at null steering on the back of the antenna. We looked at the front and back ratio for isolation. We looked at polarization to increase your signal to noise ratio. We talked about which donor cell site was best based on the PCI and speed tests, just to let you know if you have any problems to help you choose the right donor signal to target in the first place. And we talked about using the building itself to block interference, having the lowest elevation possible, and still see your target cell site from a line of sight perspective. We talked about antenna spacing to make sure we're not having noise contributions from other antennas that might be transmitting on the roof. And then using that information to choose the right antenna for the job, and the tools that are available to you, be it the portal and the alerts that we show on the portal, along with the RF KPIs or our site survey form or our step-by-step guide, and that's it. So if anybody has any questions, you know that we're always here to help you. We have our support line where we spend our days helping people get used to the system, teaching them how to read the portal in real time. If you have it connected to the internet, then we can see it also. And that way we can do all of this real time, and that's the best way to learn. So thank you very much for your time.
We've had probably 30 some odd questions. We've been trying to answer as many as possible along the way, in which I think we've got a majority of them. Several of our integrators are saying hello and saying it's a great presentation, so appreciate that commentary. There are some questions about, will this presentation be available? And the answer is yes, we make a video version of this available. If you're a partner, we'll make this presentation available through our partner resources. You know, we've also had several questions about the apps that you were talking about, and you know, what kind of you said you had a favorite, and that you used the version on Android, whether it was Android and Apple.
I want to make a comment about that because that's a fantastic question. Android only. I've not personally tried a Windows phone, but we do know that iPhones don't cough up the right information, and the information in their field test mode is often incorrect and very, very misleading. And it, not to any specific fault, it's just not something that they really support. And in order to get the information and get the information that updates every couple of seconds, you need to use an Android phone. So those are definitely the way to go.
So with that answer, is there an iOS app that you're promoting that you're in favor of?
Unfortunately not, because they don't provide the apps with the information that's required.
All right.
And that's why I mentioned it, because they do have a field test mode, but if you take a look at the field test mode, you'll see values that don't make any sense. And so it's obvious that even though field test mode is displaying values, they're incorrect.
So this is your plug for Android. Got it.
Yeah. As a measurement.
Now, as far as a speed test, do you have an app just for the speed test portion that you're promoting?
No, you know, and I don't want to make it sound like we promote anything. Everybody just has their favorites. I honestly will usually use a couple of different speed test methods when I'm at a site. You know, maybe, you know, speedtest.net wasn't, you know, they were kind of the ones that started this whole thing. Sometimes I'm just using Google. Sometimes I'll go to, you know, Verizon speed test, whatever. And I do it differently because they can give different results, right? They shouldn't be wildly different from each other. You know, the main thing that I'm looking for are things like, maybe I've got 15 megabits per second down, but 20 kilobits on the uplink. All right, something is happening terribly on the uplink at that base station. Or maybe I'm seeing just really low data rates on the downlink. So there's pilot pollution hitting the donor antenna. I need to move it or choose a different antenna. So it's kind of the trend that I'm really looking for, not the absolute values.
Great. So then just some overarching that I because we had so many questions about it, I thought it'd be worthwhile to mention publicly. There was a lot of questions on similar to that I asked earlier about when to use the Omni versus directional and a 4-carrier solution. That again, if you want to go over a little bit publicly. Again, when's the optimal time that you are going to go with really a directional antenna in a 4-carrier solution or multiple directional antennas versus using the Omni?
Right, okay. Maybe everybody's going to come up with a different percentage, but let me just kind of take a personal stab at this, which is I would only probably use an Omni antenna definitely south of 20% of the time, possibly south of 15 or 10, because it's tough at a site. It doesn't mean that it won't work. It'll work great, but unless your signal to noise ratio is really poor, it's kind of this trick of perception in order to get your signal to noise ratio up so your customer ends up seeing more bars. Yes, that does mean a better experience, but it doesn't mean that the Omni isn't going to work, right? Usually at most of the places we go to, we really always want to try to clean up the signal to noise ratio to some degree. It's a very prevalent problem out there. You know, networks are not perfect things. It takes a great deal of work to optimize an operator's network with all their cell sites and all their sector antennas, and it is not perfect. And there is a good chance that the site you've gone to in order to install a system is at one of those places, maybe between a whole bunch of cell sites where interference is occurring, and that's why they've asked you to come in the first place. So I have to always put a lot of effort, again, into that site survey. If I go there with my phone and I'm using one of these apps for my different operators and I see poor signal to noise ratios, then I'm not going to use the omnidirectional antenna. I'm going to plan on using something highly directed to clean up that problem. But if I go to a site and I see 5, 10 dB through everybody's channels, then an omnidirectional donor antenna will be just fine and a lot easier because you don't have to aim it. I hope that helped.
Yeah, I think that was excellent. We have another solution architect in here, David Beza, that is actually providing a bunch of support and hit some specific numbers too. So those people that were asking those, we did answer that offline. I've gotten this question 3 times now, so I want to make sure that that's out there. They said, what about the MIMO panel antenna? You're talking about the Omni, you're talking about the LPDA or directional antenna, but when do you use the MIMO panel antenna? Thought maybe that one needs to be answered publicly too.
So the MIMO panel antenna would probably be one of the most used antennas, actually. It has the ability to capture more than one cell site. It's not as targeted as the LPDA. If you use the LPDA, it's usually for 2 operators and you'll need to sum those. So it takes a little more hardware because you would need a splitter or a hybrid combiner if you have 2 LPDAs going in different directions. But you wouldn't want to, if you have to do that, then you really, really need to do that. But for most cases, the MIMO panel antenna is probably the one that ends up being the most used.
Great. And then there are many questions around the Wave portal itself of what access they have and when they have it and what layers of details they have, how it can be used, that we've been, again, answering individually along the way. But overarching, if you want to talk a little bit about the Wave portal and how it truly helps. I know you covered this in the presentation, but how it helps in this commissioning process and what sort of access that our partners can expect to have.
Okay, so everybody has the same access, and when you receive your hardware, you should go to the portal, log into the portal, and go look at the access tab on the bottom left side and make sure that you can see your network units at least, and by their serial number. And if you can't, when you're commissioning, you can request access, and you can do that through the access tab. You can request access, which just makes sure that you do have access to that system when you need it. Another thing that happens is, when we ask people, it has to do with having an internet connection. You negotiate with the local IT staff, your customer, to get an internet connection, ideally, so that you can commission on site and make use of all these wonderful features. But sometimes that goes south, right? They think they've opened up the firewall ports that are required for you, but they actually haven't. Those things happen. So we really recommend that you always show up with your own internet source so that you won't get slowed down by any of these site IT issues. Take an LTE modem, take a Wi-Fi extender and tether it to your phone. Do something like that so that you're assured an internet connection, and then you can quickly commission your systems. Now, once they're connected to the internet, there's a couple of obvious huge benefits. One is after you've commissioned it, that system is downloading information to the portal for you to view, right? They check in once an hour with just 2 kilobits of data, so you can go graph things later and see how your signal quality metrics varied over time and all of that. But when you're looking at a system on the portal, it knows that you're looking at it, and it sends a command to the system that says, give me real-time updates. So you've got a system installed, you can see it on the portal, you're getting updated RF KPIs about every 10 seconds or so, and you can actually evaluate what's going on. You can take a look at those alert messages. Those little colored triangles will show up if there's anything that the portal feels you should be paying attention to. And then what happens after you've left the site, right? Once you left the site, if you have that internet connection and you ever get a call from the customer, you don't need to roll a truck right away. You can log into the site remotely and you can see what's going on. You can see if there's any alarms. You can see if there's been a change in the maybe your signal level and quality or isolation or something like that. You can take a look at historically the last 24 hours or week or month on how these parameters looked. That is a hugely powerful tool. Or you can even call us, as I mentioned, and we can take a look at it with you, right? These are all managed components. So if there's something to be seen, you can see it on the portal. So we really recommend that people leave things connected to the internet all the time if they can. I would take a look at, you might want to call our support department and ask for that step-by-step guide, just because it explains all of this. Also, when you go to the portal, if you look at the question mark in the upper right corner, it has some integrated help there as well. As a matter of fact, it's the step-by-step guide was used to create the help information under that question mark. So go take a look at that, and that's already available.
All right. Is there any more questions out there? Is there any more questions before we wrap this up? Let me give people a few seconds. I'm reading a couple here. So there was some questions around you repeating some of the stuff you said around the MIMO side. I don't know. I'm guessing that's the MIMO panel of when to use it and when not to use it.
So the MIMO panel antenna is used for either the 1000 or 2000, and the reason is because there's two RF ports on each. You're certainly getting MIMO is the connection if you're using a Quatra 1000. The Quatra 2000 is a SISO antenna, but you're still making use of both of those antennas, and it has to do with even though it's a SISO setup, you're using both of those antennas, and it has to do with the hardware architecture of a 2000. If you're using that LPDA antenna, then it has a single feed on it, so you would need to split it in order to feed both of the RF inputs on the Quattro 2000. If you were using it for 1000, ideally you would actually use 2 of those antennas if you needed them, just so you would maintain that you don't want to collapse MIMO. You'd want one oriented at +45 and the other one at least 16 inches away on the pole mounted at -45 degrees. That's just if you need that though. And keep in mind, everybody, you can always get in touch with us. The questions are very healthy for us as well, because it helps us understand how all of you are thinking, make sure that we're providing the information that people need. So you can always call our support line and get in touch with us.
Great. And just a barrage of last minute questions, things like how many operators do we support? We're obviously a global company. We're covering 200 carriers across 100 countries. The Quattro 1000 is 1 carrier per system. Quattro 2000's 2 carriers per systems, but we create and architect solutions that are multi-carrier. So in the US, in which, you know, this is during US time and a large number of the people on are US today, we can do all 4 main carriers. And then we had some questions about around wave. What do we allow the end customer to see if they have an IT department or something like that? Is there a different version, or is it the same version that the installer would see?
On that question, usually customers would never get access to the portal. You have value as an integrator. You've taken a course in order to get access to the portal. That information is for you. It would do nothing more than confuse a customer. You know, it's your job to provide service, and if you have a service contract over time, to maintain it. Technically, if you really wanted to, you could have text or email messages sent to those people if an alarm were to occur, but we're fairly strict about portal access. Again, because of the value that it adds to you as an integrator. We do not hand it out to customers.
Well, all right. We're approaching our end time, and we're trying to make sure that we've answered everything either live or in the chat or email. If there are any follow-up questions, as Steve said, you can always contact us. We'd be happy to hear from you. And we thank you for all joining us today. And Steve, we thank you for your time in educating us.
Okay, thank you, everybody. Look forward to hearing from you.
All right. Bye-bye.
Bye-bye.